check something very, very important. The engine of a train produces a force of 3,000 Newton when the train is moving with a velocity. This is with a velocity of 30 meters per second. I repeat, 30 meters per second. Calculate the power of the engine. Full stop. Read it again. The engine of a train produces a force of 3,000 Newton when the train is moving with a velocity of 30 meters per second. Calculate the power of the engine. Alright? Yes, that's a standard international question. But if you're not careful as a student, it will throw you off balance. You may arrive at a wrong answer. Before I move into solving this, consider to make your comment clear in the comment section. Share with your fellow students or share with your students if you are a teacher. Give me some thumbs up and then let's see how it goes. How do we solve this? It's very simple. Let's first of all write solution. After writing solution, the next thing we are going to do is to state the formula for finding power of an engine like this. So the formula for finding power is simply P, all right? P is equal to W, meaning work done, all over T, time. All right? So with this, we have started well. But as a smart student, you must ask yourself this. You have work done here, you have time here to find power. But in the question, what you have is force. And what you have is velocity, 30 meters per second. So, it doesn't fit in at all. What do? First of all, bring out your data. The data look this way, or the parameters that the question contains. The data I'm talking about is the information that is contained in the question. So the first one is force. Force is giving us 3,000 Newton, right? That's the first thing. The second is velocity or the speed of the train, which is V is equal to 30 meters per second. We are talking about power of the engine, power of the engine. And it's not contained here, so look at it. It's unknown. It's simply unknown. What do? Very simple. We need to derive the formula suitable for solving this question using this particular formula. That's we call this relation number one. We call this relation number one. So from this, we can now generate another relation, which is given as P is equal to W all over T. If we have this, okay, we recall that W is also given as force times distance, okay? Product of force and what? Distance. I repeat, W is also given as product of what? Force and distance. That means work done in a given system can be calculated using force times distance when there is no angle of inclination, all right? All right, so when we talk about T, T is okay. So we can restate this formula as P is equal to, instead of this, we put this, and that is F times X all over T. Good. Very simple thing. We also recall that In our equation of motion, general physics now, in our equation of motion, that V is, why am I squeezing up things here? Why am I squeezing up things here? Let's try the other side. We also recall that in our equation of motion, V, that is the speed or the velocity of any moving vehicle or moving object, is giving us V equal to x all over t. Good. So look at that. X over t. All right. So with that, we have the first one. The second one is this. We can generate the third one. We now say V, P is equal to F times, we have x all over t. Yes, if we take that, can you see that? Can you see that? So we can now say that P is equal to F. In place of x over t, we substitute with V. In place of x over t, we put what? V. And then we have F times V. So with this, we cannot find the solution to this problem. We cannot solve for the solution of this problem. We cannot find it. We cannot find what the power expended by the engine according to the question is all about. So let's go. Call this equation number 2. This is equation number 1. So we have derived equation number 2 from equation number 1. The next thing is for us to substitute. And we go P, alright, is equal to, for F, this is the value of F, 3,000 Newton, right? Okay, so we do that. For F, we have 3,000, alright, Newton. And then for V, look at V, 30 meters per second. We do that, we put it there, times 30 meters per second. We're not going to put the unit now. So what does this give us? Of course, 3,000 times 30 will give us 90,000 watts W. Okay? We can still put that value in a standard form. Yes, in case the options are presented to you in standard form, you put it in a standard form. It becomes 1, 2, 3, 4. That means is 9 times 10 raised to the power 4 watts. Good. That solves it. That's the final answer. So with this, we have arrived at the final solution, which is 9 times 10 raised to the power 4 watts. Okay? It's measured in watts. Power is measured in wattage or watts. Okay? So that is it. And that is the simple way to solve this. If we had wanted to find the power using this, we were not given work done. That's the first thing you should consider. We were not given time. Time was not given. Work done was not given. So we don't need this in the first place. Or rather, time is not given, work done is not given. So we don't need this in the first place. What we need is a formula that will accommodate this. And that formula is this. That's very simple. Okay, that is it. If the steps are used in solving this simple problem are difficult for you to understand, put it in the comment section. Tell me in the comment section that these steps are not clear. I will resolve this for your understanding. But don't forget to share with your network. Share with your students. Belong to this family. Give me some thumbs up. Come on. And then comment. Give me likes. And so on and so forth. You know what? I'm going to prepare another class. Thank you.